Okay, we've got the limit of the sine theta as theta approaches pi. We do the direct substitution, plugging pi directly in for where there's a theta, and the sine of theta is equal to 0. We have the limit of secant theta as theta approaches 5 pi thirds. We do the direct substitution, plugging 5 pi thirds directly in. Now what I've done here is I have rewritten this. Secant can be rewritten as 1 over cosine theta, and theta in this case happens to be 5 pi thirds. Now the cosine of 5 pi thirds is 1/2. And once we reduce this down, we get 2. Okay, in this one here, we've got the limit of 5, and in parentheses, 1 minus cosine x over x as x approaches 0. We go ahead and do the direct substitution, plugging 0 directly in for x, and we get 1 minus cosine 0, and cosine 0 is 1, so 1 minus 1 is 0, and 0 times 5 is 0. And then, of course, we have 0 in the denominator, so we get 0 over 0. So that means we're going to need to transform this somehow. And what I'm going to do here is I'm going to multiply the top, the numerator, by its conjugate, so 1 minus cosine x, and I'll multiply that by its conjugate, 1 plus cosine x. What I do in the numerator, I also must down here in the denominator. Now what we're going to do is we're going to multiply 1 minus cosine x times 1 plus cosine x. And when we FOIL this out, right, first terms, 1 times 1 is 1. 1 times positive cosine x, and then negative cosine x times 1. Now those two terms are going to cancel out because one's positive and one's negative. And then the last is negative cosine x times cosine x, which gives us a negative cosine squared x. However, this is one of our trig identities. We can rewrite this 1 minus cosine squared x as sine squared x. And of course you can see here in the denominator, I just rewrote it. Now what I'm going to do here is I'm going to break this up into two separate limits. So the sine squared x here, I'm going to break it up so we have 5 times sine x over this x here times, and because we have 2 of them, I rewrite another one here, and then sine x over 1 plus cosine x. Now the properties of limits, there was a product property where we can actually break this up into two separate limits. Now I'm not sure if we've discussed this or not, but this is something that you'll just take as fact, and later on in calculus you'll learn why. But the limit of sine x over x as x approaches 0 is going to be 1. Now one of the properties of the limits is, remember, that you can take this 5 and bring it out front. However, I don't really do that here, but just pretend the 5 is out front here. So that's the reason we get to 5 times 1, even though we can evaluate it inside. It doesn't really matter. We have then times the limit of sine x over 1 plus cosine x. We do the direct substitution, plugging 0 directly in for where there's an x. So we get sine 0 over 1 plus cosine x. Now the sine of 0 is just going to be 0. And 1 plus cosine 0, cosine 0 is 1. So we end up getting 0 over 2. 0 over 2 is just 0. But after simplifying it down, our final answer is 0. So you can see here, this is what I claimed, that our limit was equal to 0.